Any question here? Okay. Now, with that, let's understand what algorithm for these questions. Somehow, for people who missing for the sessions, you're gonna have the video starting now, and you need to understand the questions, uh, and then get down to the video. So now, starting, we're gonna start the reasoning and talking about the algorithm. You see this a process. First of all, if we can follow these processes, definitely we can get an answer for if we starting at any bell, any hill, we can get the answer as to at the final when the chain effect stop, how many hills we can destroy, right? So the brute force is rather simple actually. Is that why don't we just traverse each hill? We start with each hill and then figure out as that given I hills, well, how many at I hills at the first round, how many total hills we can destroy due to this chain effect, and then you can using a for loop go through and then finding that the total number and just basically find the maximum one. So so that's why for this question, the only limitation for you to decide to go this route is the variable. So the n is 100, stands for their n hills. Definitely this ends in your function. Your algorithm going to play with these numbers. So this n going to decide the time complexity. And then look at this. If we decide the brute force, so-called simulation, so the code is going to be starting with a 4. 4 going to go from every bay hill, right? Let's go to my my coding coding pad. So this is very similar to our coding session, isn't it? Let me go to my, hold on a second, all right. So naive. So if we start at hail I, based and follow the simulation, we can have the result of how many total hails that can be destroyed. By chain, let's say chain explosion, right? So this is your naive thinking. So no matter we are talking this is silver or even higher level, always started with a naive thinking. I think we are trying to build out the curve gradually and really nice from the bronze class. Now we are doing that same thing in the silver, but at advanced level. So starting with the naive thinking, if this naive thinking can deliver the questions well within the time complexity, did it, great. If not, then you're going to jump in to identify where is redundant and where is you see repeated calculations, so then you can cut down and optimize it further. So, so with that, we can definitely simulate the process. And like said, the restriction is the time complexity. Sorry about that. I keep have people joining, so I have to have a kind of admit the people. So the restriction of the simulation is about the time complexity. Now, we have the n hills equals 100, which is the max. So which is a 10 square. Now, let's deliver the pseudo. For the pseudocode, so then we can understand what is the total complexity, and then we're going to calculate whether or not this is going to within the boundary for USACO, for bronze level. Now, we want to start at each hill. So we're going to have an outer for loop. So the outer for loop is start on each hill, let's say at I, for the first explosion, right? And then within that, so basically you want to chase it down. What is chasing down? Simulate, right? Every round you have the range go by 1, plus by 1, and you're checking whether or not you can reach anything, and so on and so forth. And with that, clearly you want to maintain the results somewhere here, right? Blah blah blah. And with whatever you got, start from the I, you want to update the result as accordingly. So this result stands for the so far. Let's just be self-descriptive. So far max, all right? And inside of that, think about it. What you're gonna have is uh, I want to comment some things for, especially for bronze levels and for people starting into programming not very long. That is, it's a difficult just code it out. So that's why I recommend you start with pseudo. And even on top of pseudo, you're gonna think about something like that. For that logic going, what variable you need, what variables you have to maintain. For example, as to answer you're going to return, this is very simple. So you're going to have a so far maximum to update answers from your for loop. But as to this for loop, what variable you have to maintain? For example, 3, 4, 5, 6, right? 8, 13, right? That's the questions. Now, let's say if we start a simulation as 5, and based on the simulation procedure, we have gonna go to left and go to right. With what? With the steps. Who defined that step? Well, you need a variable to define that step, isn't it? So you kind of also need a range, right? Maybe you start with a 0, right? Because how do you know this I you need to go left for how many steps, go right for how many steps? So you had to maintain the range, right? So put down there. And then what else? And the other one is that at a certain given round, what is the boundary? For example, you started with I, and the next round you're gonna starting with 4 and 6, right? Let me using that. And this is like the boundary of the explosion so far. You start with a 5, and then you reach 5, you reach 6. This is in the second round, right? What is third round, folks? Third round is based upon the boundary of the hill in the second round. You're gonna add the range as the number of range as accordingly, which is 2, by the way. You're gonna have 3 be included and 8 to be included. Remember, for third round, the third round is based upon your second round. For your left and for your right, you should start on your second round boundary and add on the range so you can go to third round. Hopefully, you can have hills within that third round. So who gonna tell you this boundary? Who gonna tell you that? Well, nobody. Then you're gonna maintain that, right? So clearly, you need another 2 variables. Maybe you can go like so this is another thing is when you guys trying to uh, declare variables, try to make sense, all right, in terms of name. So for this, let's just say left, right, and right. So here, left and right stands for what? Leftmost index and rightmost index that blast can reach to at given round. All right, that makes sense. So that you can simulate that. So that's a recommendation for people that try to define the variables that can help you to simulate the process. You need to know what is the range at the given round, and you need to know what is the boundary from previous round. So that's why you maintain the range, you maintain the left and right. All right. What else do we need? When to stop, correct? If you look at for this for loop, what you want to do is start a simulation. And start a simulation, well, when to stop? How to define that? So you're gonna need a either if condition or a y condition. Clearly, for this simulation, is not gonna be just a one-time things. It might be several round. So you need a while loop. So what is a while loop here? What's gonna put in that while loop? Is that when there's no hail, let's say at the i's round, jth round. For the jth round, you find that okay, this is a boundary for j minus 1th round. And then you figure out, you know what? I'm starting from the boundary from j minus 1th round and plus from the range. Guess what? I don't see any hills within that. So that's gonna be you're gonna cram in by conditions, right? So you can make this is a little in terms of a bet of reading fluency. You can declare another two variables. So here's you can think about is you can put a boolean, let's say explosion stop for left side, and another variable called boolean explosion stop right. So the physical meaning for these two folks is at the given round, whether you can still go to left, whether you can still go to right, because there's a situation is you can keep go to the right, however you stop at the left. So when both and stop, literally, this while loop stop. You could, using other logic to represent these two Boolean variables, it's going to be same things. And for our demo, let's try into using a clear variable that stands for that. So that's kind of the while loop. The while loop going to be this. When you have hills within the range for the left and for the right, you're going to get into this while loop. So this while going to be what? Going to be clearly you're going to start with a false, right? When you still can go to left, or when you still can go to right. So that's why we have such a logical OR. And then you're going to go into this while loop and put whatever logic you want to put there. So we're going to put this in our coding parts, but whatever it is, you're going to have a outer for loop, and then you're going to start with each I. So this is O of n already, right? Time complexity. And then for this while loop, remember, if for here's, if you just think about it, you know, the worst case, in each round, you can only get one hill, either left or right. Then what is the time complexity for this while loop? This is going to be O of what? So O of n, right? Linear time, isn't it? What if you're picking three, for example, at the first round? You know, each round you know can only have one hail, you know, within the range, so on and so forth. So then you had to do that for n times. So another O of n. So going back for this pseudo, so this is a clearly O of n squared time complexity. Then what's scale of n? N squared. So this is going to give you 10 to the power 4, right? 10 to the power 4, well, it's okay. Actually, you can still go ahead with, even though if the input is 10 to the power 4, you can even still use a linear time algorithm to deliver that. But for this quadratic, for this n squared, it's 10 to the power 4. It's okay. Then with that, you relax such a restriction here. So you are good to go ahead with the simulation. All right. And the other part is literally deliver the code. So I also want to quickly show that. But for this algorithm, the point we start with the simulation is very basic. It's integral parts of a whole questions or just literally one step. So people need to be very sensitive to the time complexity for simulation. And like I said, derivative based on simulation that could associate it with data structure, with additional algorithm, or combine to deliver that. So simulation actually have different levels. Well, for such level is a basic level. So we literally simulate the whole process, and then we get answers. And then if you can recall the scheduling conference room questions, we also use simulation, but that is another level simulation. That is, we simulate from the angle of scheduler. And from that angle, we cramp in the conference room. So that type of simulation. But as to when we schedule the conference call, we associate it with another algorithm and data structure to make a better time complexities. So starting with that, I think it still be good for all levels, bronze and server, and review one more time again with a very naive simulation, basic simulation solving solving approach. Okay. Now, any question here? If no questions, we already burned about 30 minutes. So let's code it out within 10 minutes. Uh, so there's a lot of worship bottle parts here. I don't want to spend time as to what is template and how to submit it. If you have questions, and come to me offline. So these questions, we need to deliver what is, I need to find a big screen to be honest. So it's bugging me for a while. So this question is called what? It's called angry, all right? So let's go to angry.
You can split screen it.
Oh yeah, right, Andrew. That's right. Okay, angry. So let's just copy the templates, which is read the file and output the file. So the next points. All right. So uh, and you had to change the input file to be angry for output also. Then first you're going to read the data, right? The data clearly, first number is about how many hills. You're going to have n. So this is numbers of hills along the 1D farm, right? And what is second? Second is literally what is the location for the hill. So this one, you're going to have a 1D to capture that. And clearly you have n hills, you're going to have a for loop. So this is a problem with Java is a lot of typing. If you guys are using C++, it's going to be very comfortable for this portion, but it doesn't matter for now. Then capture all the locations into that. So again, int next int. All right, so you capture the total number n, so you put all the locations in this 1D array. Then you can close this file. And in the pseudocode, I didn't mention, but clearly this one. So the input is not necessary to be sorted. You had to sort it out. So you're going to call arrays and just position. Since this is a natural order, we already sorted out as accordingly. So mostly you can just put everything here. So not necessarily you're going to see a lot of things bugging you. Folks, look at here. What is a sorting algorithm, time complexity? So this is already n log n, right? What does that mean? As long as your algorithm, I mean, this one actually doesn't work and it doesn't do anything better to deliver code of n log n, but you can actually deliver that. But the point is, in other level classes, level questions, if the input variable is super big, but you have to sort it out, so which guarantee your following algorithm you can play with n log n because it already set up the boundaries, the working boundaries, all right? Now you sort it out. Then let's go to the simulations. Remember, what is the first variable we need to maintain? That's the results, right? So we already have that, just tick it. Now, what we want to do is we want to starting at each position. So definitely we're going to have for loop. So this I stands for the index of each position. So I less than n and I plus plus, and go into that. Now what's next? Remember the pseudocode? You had to what? You had to maintain the variables. One variable is very important is at any given round, what is the range, right? So you can have int range equals 0. So the physical meaning of the range is what? Track the explosion range for a given round of blast, right? And what else? What else? What is leftmost and rightmost? Don't forget about that, right? Left equals I, and right equals I. Because you're starting at the I, so the leftmost and rightmost index of the boundary of the blast is at the I. So it's an initialization at theirs. Physical meaning here is left and right stands for leftmost index that blast can reach to, and blah, 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 right also, okay? And what else? Pretty much we can deliver this while loop, right? Remember for this while loop, this condition is that when you still can go to left, and also, or you can go to right for explosion. So who gonna tell you that? Well, you can use a logic as to distance, whether or not for the given round of the index of the hill versus the boundary, the difference is within or not within the range. Or to make the reading fluency a little better, why not you declare boolean? So this is the same as the pseudo at the false, and boolean x stop right false false. Okay. Now for this while loop, in order you can get into the while loop and do meaningful things, so you had to making sure stop left or not stop right, isn't it? So then you can get into the while. Otherwise, you can exit out. Now, for this while, what's the logic here? First thing is, that's all I mentioned many times in our session is making sure your variable, physical meaning of variable is consistent. When we get into the while loop, what we need to do, we want to check in the nearby hill, whether or not it can be destroyed with a given range. So what is your first step? Your first step is update the range, isn't it? So range plus plus. So you actually go into the second round. And what's next? Next, you're going to think about every time you go in this while loop, you want to making sure these two variables maintain well, right? So the second step is you want to check whether or not for this new round, these two variables still going to be maintained as false or going to be maintained as true. So at what point it's going to be maintained as false or at the true? Well, one thing is very clear is if the left already equals 0, remember you're starting at the left, folks. If this is already 0, you do not have any hill on the left part. So definitely this variable have to maintain as a true. Or if not, if the position at the left minus position at the left minus by 1. So position at the left minus by 1, that is the hill left to the left boundary. If that range, you know what? If the differences is greater than the range, well, unfortunately, this explosion stop left can't be true. Correct? All right. Now, what is next? Well, you can do the same thing for the right, right? So we're going to leave it at the later parts. So if you get down to here, which means you had to check in if this x stop left is not true, which is false, you had to check in for more hills. So here you got to have if statements, if x stop left is a false, which means you can still go to left. Then here's you're gonna keep checking over the left with a given range, correct? And you're checking within this range. Where's my annotation? This is your left, right? And this is a range. So what you need to do is checking here, checking here, checking here, checking here until here. As long as any point you have a hills, and destroy it, and then maintain your left to that positions. So actually here for the bronze levels, it's okay. You can just go step by one step by one step and so on and so forth based on index. But for server folks, clearly you can optimize this searching by binary search. Since all the left portion, you know, the position already ascending order, in order to finding the smallest index that's still within the range, well, definitely can use in binary search to optimize it. But to be honest, for this simulation question, for the input number level, I mean, nobody care, right? Anywhere still within the boundary. But you should have such a sense for server. Binary search need be used to further optimize it. Okay, so if you can still go to left, then you basically want to go to left, right? See if any here there's. So you need to have a variable, folks. A variable keep go to left and compare to the left. So here's in order to do that, so you can maintain a L, which is starting from left, and then you're going to have a while loop. While the left is still within the boundary and logical end, the position left minus position L as long as within the range, guess what? L minus minus. You have to keep checking on that. Keep checking on that. For the L, go decrease, decrease, decrease until the points. The L pointing the hill, which is out of the range, you get out this while loop. All right. So then you want to maintain your left. Don't forget the physical meaning for your left. Leftmost index that blast can reach, can destroy. So left has to be what? L plus by 1. All right. So let me put a comment here. Is a server actually this is all requirements also for bronze? Like I said, for people to be very solid to passing bronze, you also have to deliver basic server. So binary search to further optimize this portion to log n from O of n, right? All right. So pretty much we are done with the left. Well, to the right is very similar. So you're going to checking whether or not x stop right should be maintained as a true or false. So if right equals n minus by 1, and also position now, you're going to have a right plus by 1 minus position right, right? If this folks are greater than range, you know what? Unfortunately, this folks going to be false, going to be true. Right? And then same thing, if you can go to right, then going to be same thing, right? You're going to maintain a right, starting from right, and have while loop where the R going to less than n, and a logical end, and position from that spot and minus the boundary. The boundary is still at the right. Don't forget about that physical meaning. And position at the right, if still within or equal the range, and right and R plus plus, correct? And when you exit out the while loop, you have to update the right boundary. The right gonna be what? R minus by 1.
Wait,
Hello? Question?
yeah, could you explain the part where you set x dot right to true?
Sorry, Frank. Your background is kind of noisy. Either you come closer to mic or you can enter the chat box. Can you try again?
Yeah, sorry, my mom's cooking. Um,
Oh, okay.
yeah, I don't get the condition where you set x dot right to true.
Which condition?
The one where you set x dot right to true.
Which line? Sorry, I still cannot hear clearly.
44.
44. Okay. Um, this condition, if condition, we want to checking whether or not for next round, we still need to go to right. Actually, for even this round, you need to go to right. So if right, which is the boundary, if you already at the rightist hill, do you think you can go to right? No, right?
Yeah, but I don't get the second part.
The second part is if the right is not at the rightmost index, but you see here is your right, right? And this is a right
Yeah,
plus one. If the position for next boundary is out of the range for your current boundary right, so which means you can never go to right, right?
so basically, if the next explosion isn't gonna hit anything.
Exactly. It will not hit right plus by one, right?
Okay,
Makes sense.
yes.
It's a very similar to line 31. You see, we check on left also, right? We check on left minus by one in terms of position difference.
Yeah,
If it is out of if it is out of range, just we don't need to go to left anymore for this
okay,
round and also for following rounds, right?
okay, okay.
Okay. All right. So I think we delivered the while loop. So when it exceed out the while loop, so we're gonna have what? We're gonna have no matter what, left and right, gonna pointing to the the hill that's starting from the ice that can reach at the most either left or right. So leftmost or rightmost is well represented by left and right. So then you want to update your results, right? Don't forget you have a result here. And you're going to update here. So your results just need to find the maximum. What is the maximum? What is for this given round? It's going to be right minus left. Don't forget plus by one. All right? And that's going to be right. Going to be the results, and then print it out. And then uh, also, this is the parts I want people to do instead of just checking your code, making sure you go through one more time. Think about this round. You're going to explain to your people and what's your algorithm, and this is what you have down. Beside the parts, you already think aloud and deliver the code. And you see, this is simulation problems. And first of all, we capture the number of hills, and also we're making sure we capture all the position of the hills, and then we sort it into ascending order. And then we're starting the simulation. The simulation is starting at each I stands for the index of the hill. We're going to check what is the furthest boundary. It can go to left or it can go to right. So that's why we had to maintain the range, because at any given round, we want to know what is the range. And also we want to know what is the left boundary and a right boundary from the previous round, isn't it? And also we have two Boolean variables to tell us to label whether left is stop, right is stop, right stop. So then we can stop, explode the left or right. And then we are into this while loop. This while loop basically delivers the simulations. So while you can go to left or you can go to right. And then, okay, this is a new range, plus by one. The first if is going to check whether or not we can still go to left, right? If left already at the left is if at the zero, or if it's not zero, but the next hill is out of range, then you cannot go to left, which is true, right? Which is explosion stop. Left, go to left is true, cannot. And the second if is if you can still go to left, well, let's go to left. And here the matter is we're going to maintain the variable I, and as long as I is still within boundary, well, checking left minus the position L. The left is a boundary from previous round. The L is a new health you're going to destroy within the range. So you got to keep checking that. As long as within range, decrease L by 1 until it's out of range or does not satisfy this. And then maintain your left to be L plus by 1. And then for this for the third and fourth, which is very similar, so we're going to checking for the right boundary. If the right is already at the rightmost or the nearby hill is out of range, well, cannot go to right. If you can go to right, then let's go to right as long as R is within the boundary and the position R is within range to reach the right. Then R plus plus, and at the end, right equals R minus 1. And then we're going to update the results, which is right minus left plus 1. All right. So that will be it. Right. Well, capture what we want to deliver for such a very brute force, very basic simulation. Like I said, for this portion, you can optimize it. All right. Look at here. If you optimize here, and then your total time complexity is going to be n log n. So this exactly sync with the upper boundary limit from your sorting algorithm. This is n log n. For this portion, you can cut down to log n. So everything's n log n. It's just like a very beautiful. But for these questions, even though you deliver n squared by using brute force, it just be fine. Okay, so with that, you can go ahead and check your code. So it's a super easy to register account, and go ahead to do that if you haven't, for people who are not taking my class, and then just submit it. Okay, so somehow we're not using the right file. Let's see what's going on. File missing. Let's go to my file. So angry. So we have an angry in. So I'm just checking. Okay, I don't think I save it. I think that's a problem. It's angry, and this is angry out. Okay, let's try again. Java, choose file, and go ahead with it and submit it. Okay, if you look at the time, it's very consistent. It's about 200 milliseconds. And like I said, this question is not challenging because the ends are super small. A follow-up I want to offer you guys is optimize these questions. Let me give you the n could be 10 to the power 5. What's going on with the... So for this n can well decide n squared is fine. But think about it, what about the n going to be 10 to the power 5? If this 10 to the power 5, most likely n squared will not work. So, and then go to the code, try to optimize for this portion, and making sure this is going to be log n, and then the total time complexity is going to be n log n. So you can pass it for the follow-up. Right? So that would be the demo for deep dive into Angry Cow. Right? So I hopefully for the questions, people can recap simulation, recap time complexity calculations, and also recap binary search also. We have a binary search topic later weekend for lunch break, and stay tuned on that. All right, so this is our first session, which is very warm up, question bottle level. So definitely I would say that's a good start. Any question? All right, if no questions, I'm gonna let you guys go, and I'll see you guys next weekend for the lunch break. All righty, bye-bye.